So in this video, I'm going to show you first how to actually use some images that you build on a cloud provider where you may not have graphics or may you do not want to suffer the latency of SSH-X if your server is far away, or if you do not have nested virtualization support, and then KVM will not really work and your emulator will be super slow. And for these reasons, you want to actually run whatever you build on the much stronger machine that is the cloud. You want to run it on your machine that has the nested that this does not even need nested virtualization, that has a GPU, that has KVM, that has all the kind of things you need to work in a normal way with an emulator. So here what I am showing is a very brute force way of doing it. There are actually SDK extraction scripts which are the right way to do it from within Poky. But I'm going to show the rationale behind runqemu and how some of the things work. So here you can see that I tarballed my distro folder, which is this one, QEMU x86-64, that is under temp deploy images. And if I look at the tarball size, it's going to be this one. And if I'm going to look at my folder size, then I will see that it is a little bit bigger. So 371, for example. Okay. So let's have a quick look at the folder. It actually has two builds. So let me put it a little smaller. You can see that the most recent build, that is the one that will be considered if I just do runqemu without any parameters, is the one for which the symbolic links point to. So I can see that busy image is a kernel, that is this one. It's going to be actually the same kernel. It's going to be exactly the same one here as well. And we can see that we have a qemuboot.conf file for core image minimal, and for each one of the builds, that if we did multiple builds with like different parameters, then we'll have different dates. But here we're going to look, for example, for the same date. As you can see, we're going to have qemuboot.conf, rootfs, that is our root file system. You can mount it as a loopback device if you want to. And we're going to have a manifest that's also textual. Then we're going to have this rootfs tar busy2, okay? And we have test data. So this is going to be linked to the ext4 here. The manifest will be linked, and the boot.conf that we'll cover soon is going to also be linked. Also the busy2 will be linked, and this will be linked. In other words, everything is linked for the core image minimal. Now later I did actually in this build folder two things. I did bitbake core image minimal, and I did bitbake core-image-sato when I displayed the splash screen. This is the same thing that I did, like not on the cloud, but on the previous video where I demoed the replacing of the splash screen. So I did the same things on the cloud, okay? So you can see that the names are pretty much the same. However, here you're going to have core-image-sato and pretty much the same files, okay? What we also have is modules, that here we do not have like, okay, the image name, but we do have the machine qemuboot64, and in this particular way it links to a particular build and module that was actually the exact same for both the core image minimal that I built and the core image sato that I built, just like the kernel itself. Had I done modifications and rebuilt the same target, for example, then I remind you we would have like the same link would point to the most recent one, that is what the qemu conf file, qemuboot.conf, would be used for in order to save us from writing a lot of parameters for runqemu. If you remember, one of the parameters that we met was no graphic. That when we ran it like on the cloud, when it just wanted to run on the very same terminal console that we're using right now. So there can be a lot of other parameters like telling it which root file system to use and so on. Okay, so conf takes care of it for us, and the links will point to the recent one, where we can of course add it and replace it if you wanted to. Okay, so these are some of the files. So I'm going to now go ahead and quickly copy this file that I zipped, that I tarballed. I'm going to copy it into my local machine. So we can see that I'm going to SCP and it will take some time. So I'll pause and then resume later. It takes too much time in my opinion. At the meantime, let's quickly look at some of the configuration files. So I'm going to go ahead and look at the core image minimal qemu x8664.qemuboot.conf. So you can see that it has a config BSP section. Deploy dir image tells us what is the default like path for all the files that like we saw, like the rootfs, kernel, and so on. And then we have here several links and the image name itself. Image name, if I build several images of the same target, like core image minimal, and like on different dates, then I can replace the image name and runqemu would automatically run that one if need be. Okay, so this is like the kernel image type, machines like for the BSP. Here I can actually go ahead and modify all kind of QEMU options. Default file system. This is the kernel that I use. I can also modify it. And we have network parameters, for example. We have other parameters of QEMU. We use virtualized for all kind of things. Here we say that we have like a serial. This is for the core image minimal variant. And we see the tunarc, which is also related to the BSP. And if you just want to run the emulator, you don't really need all this. If you want to work on a development mode, and in particular want to do some more efficient things using the QEMU supported NFS and rootfs mechanism, then you can actually take advantage of these ones, not necessarily in your build system itself. On my Yocto Project courses, on my kernel development courses, on my security research courses, I rely a lot on using a QEMU build of Yocto Project and working on the root file system without like building on the same machine. So this is an example for the core image minimal, and I will also look at the core-image-sato qemuboot.conf, and here we can see that the file looks pretty much the same. Okay, now it looks the same, and we have here some differences, like we still have options like for serial if I want with the serial, but I can change it had I wanted to. Okay, so pay attention like to this. Here we have, I mean, most of these things here are pretty much the same. We can customize the machine that QEMU sees itself, and the kernel here is the same. And we have here all kind of parameters that may be interesting for us. We also have here like memory parameters and so on. So let's have a quick look like what is the difference between these two. Now let me tell you something very important. In order to like the moment you have like a screen and you have like the same device drivers, then the change between a textual console and like a graphical console is merely a change in software. That is what you do when you initialize, as we saw when we did the framebuffer the splash screen demo. We wrote to dev fb0, and this is when we move like to a so-called no console mode, like graphical mode. then this is pretty much what we do. Maybe I will do a talk about these kind of things in the future. So this is for Sato, what we have. And let's look at, again at the core image minimal. In the core image minimal, we actually see the same parameters more or less, all right? So there is no too much of differences between these guys. If I go ahead and do diff of minimal and Sato, then these are the differences, okay? So we can see, for example, that for Sato, we provide more memory for qemu image, okay? So these are like the differences. So after a long while, which is one of the reasons that this workflow with cloud is annoying, and some of the considerations too, if you have to work with a server, have it very strong and very close to you. So we can see that after a while, we actually have our tarball. I'm going to extract it. And after I extract it, I will actually show you how to use the extracted tarball in order to modify the current temp deploy directory. Now let me show you what I mean very quickly, and then we'll go back to the tar. So if I go to my poky distro, I will see that there is a script directory. Now scripts contains quite a lot of things that if you want to work around and just run a particular one, for example runqemu, which we're going to look at now, without having the other ones in your path properly set, then you may run into some issues. So the workaround and the trick that is going to be used would actually be, if you do not extract an SDK, which is something I'm not going to cover now, to source the open embedded init build environment script and override one of the environment variables. So when we do runqemu, what do we actually get? So let's have a look at scripts runqemu here, okay? So runqemu, it's a Python script, okay, that actually knows to explain itself pretty nicely. So it says, first of all, that, hey, like, here you have like all kind, in order to run the script, then infer path, either init build bake or source OE init build env, and it's going to give some hints about having qemuboot.conf and so on. Now actually I can go ahead and run qemu with all kind of parameters, okay, which is the usage here. So I can give it all kind of variables in order, whatever you have like in uppercase, you can just give the file name itself. This is not a name of a parameter, this is what you substitute. And the other things, for example, can be no graphic that we met already. SDL, GTK are going to be, for example, what is going to be the backend for the graphical toolkit, and serial we saw on the conf file. KVM is something that I was actually sure it's going to be on by default, and apparently it's not on by default, if I see this correctly, and so on and so forth, okay? So here are some examples, and we're not going to get into this one too much, okay? What we are going to do is we're going to run qemu, which right now doesn't exist because I did not source the directory, and modify the directory to be this one, okay? So I'm going to go now and source OE init build environment, and I will use, it doesn't really matter what I use now, okay, but I'll use the original folder that I used for the previous splash screen demo, okay? So it really doesn't matter what I do now. The important thing is that if I run, for example, this one right now with runqemu, then I will be running what I did before. So let's give it a shot. So runqemu, and this was supposed to be default, but let's give it a shot anyway, okay? kvm, and the latest one was core-image-sato, okay? So let's have a look at this. It needs to set the tap interfaces. And we see the Yocto project. Yeah, this is much faster. The previous one was not with kvm. Okay, so this is like what I did before. All right, so I'm closing it. Okay, I could go ahead and rebuild with my splash, but I replaced it at the end of the previous video. And now what I'm going to do is actually something a little bit different. So I want you to pay attention to what's happening here. What I do, run qemu, I see that the paths are these ones, okay? You can go ahead, pause, and take the time to actually look at the path. But now I'm going to do something different. And in order to do this something different, I'm going to do a little bit of cheat, okay? So I'm going to see who is runqemu here. It's script runqemu. And I'm going to just try to run it without any environment variable set. So it tells me, hey, cannot find the qemuboot.conf file, and deployed here image is null. Now, if I want to go ahead and modify the directory, okay, and I want it to actually go ahead, I did not want the busy, I want to hear the qemu x86 for. If I want to take the configuration files from this one, then look what I'm going to do. And remember that we have here the different paths, okay? Now, what I'm going to do is this. I'm going to export, just like we saw before, this deploy dir image. So that's what I'm going to do. And if I now run the runqemu script, let's see what's going to happen. Then look what it does. Pay attention. First of all, it runs core image minimal actually. Why core image minimal? Because now if you were fast enough, you could actually see a very, very, very quick splash screen on the non-graphical version. I already explained you more or less what are the differences. The differences are what the software does. So let me get out of here and just make sure that like you don't miss it. You can look at the path here and see, convince yourself that I'm running it indeed from what I SCP'd earlier. And now I'm going to do runqemu again without kvm, and it's going to be much slower, which gives us probably better chance to see the splash screen. So there it is. You see how slow it is? So that is it, okay? So kvm is one of the most important optimization boosts when working with any virtual machine that is that can use kvm. So we can see that we overridden it by exporting the deploy dir image, which is good. Why? Because it means that we can now work on our instance on the cloud and then copy it and edit it for our needs. So let's see what we actually did here. So this is actually the layer that we had in our first or second demonstration video, and we did not touch the conf, we did not touch the recipes of the demo right now. Okay, let's have a look at recipes demo. So it's still the Corona opinions. Now look what's going to happen in recipes core. If you remember, when we wanted to override the splash, then we actually had under Yocto projects meta poky, we had a bb append file. Okay, now let's go to meta PSCG recipes core, and here I added another folder that pay attention, as you saw in the Yocto Project splash screen, is currently ignored, and I will explain very soon why. But the interesting thing is that I did the following. In core image minimal bb append, and let's see what is the difference here. I actually added this guy to image install, psplash. I do not need it for core-image-sato because psplash is included in the core-image-sato. So with this one line, I added a splash screen. Now, the other change that we see here is that before my layer priority, this is the layer conf, was 9, where the bb file priority PSCG, my layer priority, now is 4. What are these priorities? So I mentioned that you have several ways to specify in each layer, like where to take append files form and where to take like the bb files themselves. The idea is that when you append, then you may have different bb appends for the same base recipe, and you may want to choose which is the preferred one. So there is a way to select preferred version or preferred provider, which we're not going to cover now, but listen to what I said, because if you want to manually specify something, you can do it just for like a particular recipe. And there is a way to say, okay, my layer is more significant than yours. Now, if you look at the recipes, for example, of what we have in, let's have a look at tutorials. Poky Zeus. Let's say meta. It will also have conf layer conf. You will also see that there is a priority, bb file priority. This is an override, equals 5. So if my priority is 9 and this priority is 5, then my bb append will be taken before this, okay? Of course, the bb file itself comes before. If it's 4, then it means that whatever happens next is more important, which is exactly, whichever is like higher number is more important, which is exactly the story of the recipe we saw in the previous video in meta poky conf. This is where it took the Yocto Project splash screen that also has 5. Now I don't need to go over all the textual things because I can do bitback layers, show layers, and then it's going to show me the layers with their priorities. So now I can see that my priority is lower, and I can actually do something that helps me to understand better what is going on. I can do show appends. And then for each recipe that has appended files like busybox, like core image minimal, that is actually what I appended to, remember? When I added the splash screen, then it shows me the appends. Now, here's the interesting thing. In psplash, we have 2 append files. So here we have meta PSCG, which is the lower priority, and then we have meta poky, that is the higher priority. So what happens is that we take the appends, and the higher priority here goes last. So this is why we are going to take this one. Now, what I'm going to do after that, when I show you how to reconstruct everything, is that I'm going to go and put my layer like in the right priority, the higher priority, and then you will see my splash screen. This will be in the next video.